Here we are given two inequalities. The first inequality is 1/2 times x is less than 3. The second inequality is 3x minus 1 over 2 is greater than 4. And these two inequalities are given with the word or in between. The word or indicates a union. So we're taking the first inequality, or rather the solutions to the first inequality, and unioning those numbers together with the solutions to the second inequality. Find the graph of this compound inequality. Compound means that we've unioned or intersected the two sets together. Okay, the first thing we want to do, since these are rather complex, we want to simplify each of the inequalities before we start a graph. So step 1, simplify each inequality. The first inequality, 1/2 x is less than 3. To simplify means to get x alone on the left side of the inequality sign. So multiply both sides by the LCD. The least common denominator in that inequality is the numerator 2. The denominator 2. So 2 times 1/2 x is less than 2 times 3. Multiply both sides of the inequality by positive 2. Simplify, we get x is less than 6. That's a simplification of inequality 1. Then the word or for the union. The second inequality, we're going to get rid of the fractions by multiplying both sides of the inequality by the LCD, which is also 2 in this case. So 2 times parenthesis 3x minus 1 is greater than 2 times 4. We must distribute 2 across the parentheses. Oh, no, we don't. It's going to simplify. It's going to cancel with the 2 in the denominator, and we're left with 3x minus 1 greater than 2 times 4 is 8. Okay, erase that. We're not ready to put a circle around that yet. We need to get x alone on the left side. So add 1 to both sides and divide both sides by a positive 3. We get x alone on the left side. We get x is greater than 3. Thus, we have the simplification. X is less than 6, union together with x is greater than 3. Okay, we're going to graph these two inequalities, these simplified inequalities, and stack the number lines to get the union. The first inequality, x less than 6, graphs on a number line of x values. X greater than 3 is going to graph on a number line below, and then the union will be graphed together on the number line below those. Okay, so the two pertinent numbers here are 3 and 6. The smaller is 3, so it goes to the left. The larger is 6, it goes on the right. Line them all up. Okay, first graph everything that's smaller than 6, and do not include 6 because there's no equal portion in the inequality. Put a round bracket. For x greater than 3, we're going to shade everything greater than the number 3 to the right, and then open bracket because there's no equal portion in the inequality. Now for the union, we're going to look at the region between 0 and 3. We see that there is shading only in the top inequality for values of x less than 3. Okay, so that is enough to get shading to the left of 3 in the union, because to be in the union just means that you are a member simultaneously of both sets. Of either set, either the first set or the second set, or it could be both. In this case, the values of x smaller than 3 to the left of 3 are included in the first set, x less than 6. You can see that in the graph. So it will be included. We will shade the region less than 3. Now for the region, let's look at the region between 3 and 6. We have elements between 3 and 6 in the top set and in the second set. So that's more than enough to put it into the union. Remember, to be in the union, you just have to be in one of the sets or the other. So the values between 3 and 6 appear in both of the sets above. That's more than enough to put them into the union. So shade the region between 3 and 6. Now for the values of x greater than 6, the first set, x less than 6, does not have any elements of x greater than 6 to the right of the number 6. You can see there's no shading there. But the inequality x greater than 3 does indeed have shading. It includes the values greater than 6. Well, that's enough to get it into the union. So shade the values of x that are greater than 6. Now, we're going to put the arrows on each end, of course, because these things shade all the way to negative infinity and all the way to positive infinity. Now, at this point, we also notice that the 3 itself is shaded because it is included in the top set, and the number 6 is actually shaded right through. It's included in the union because it's included in the second set. And once again, to be in the union, you just have to live in one of the sets. So we have the entire real number line for our answer. Let's put a box around that graph because that graph is part of our solution. Okay, now the next thing we're going to look at is writing that solution in interval notation and then write it in set notation. First, interval notation, everything from negative infinity to positive infinity with open brackets on both sides. And then for the set notation, we just use the strange R, which stands for all real numbers.